2023. My name is Firman. I will present an article with the title Effect of Yield and Proximate Quality of Activated Charcoal from Palm Cell on Variation in Air Flow Rate with Partial Oxidation Method. I would like to take this opportunity to convey that the research team has four persons, namely Firman, Siti Hamidah Muhammad Stapar, Muhammad Irwan, and Siti Sahraini. Based on the data from year to year, there is an increase in plantation area and CPO production. There was even a significant increase from 2006 to 2018. Based on this data, will automatically be an increase in biomass waste. According to Prasastan in 1996, each fresh fruit bunch production result in a production rate of 26% CPO and 7% palm cell. Through the conversion of this GVO, the potential for sales reaches 13.8 million tons. Assuming the palm cell capacity is used for activated charcoal, then the potential produce activated charcoal from palm cell is 1.6 million tons. This study aims to determine the effect of air flow rate on the quality of proximate analysis of activated charcoal according to Standard Nasional Indonesia or SNI number 063730 using the partial oxidation method. As it is known that the air is rich on oxygen and nitrogen. In the partial oxidation process, oxygen is still used as a source of oxidation of the cell material. At this stage, the cellulose and lignin will undergo oxidation so that it will slowly open the cavity starting from the macropore, mesopore, and micropore position. It's known that the size of the macropores rank above 50 nanometers, mesopore between 2 and 50 nanometers, and micropores less than 2 nanometers. At this stage, although the shaft has started to form, it still contains impurities in the form of tar, as from combustion residues that stick to the pores. At the same time, air rich in nitrogen will act as an activator and scrape the dirt that is in the pore category. Of course, this will be proven through the proximate test and idle number test. The following is the design of the equipment that will be used in this research. There are several parts, and standard operation procedure in this process are: the first, input 5 kg of palm cell at the top of the reactor, and then turn on the fire of the bottom as an initial combustion for 5 to 10 minutes. Turn on the compressor and set the airflow rate to 20 liters per minute, and turn on the condenser cooling water pump. Record temperature, accommodate the condensate, A process is carried out for 5 hours, then turn off the compressor, leave it for a few hours. Take the activated charcoal produced at the bottom of the reactor. Next, perform step 1 and so on for flow rates on 25, 30, 35, and 40. And then proximate analysis each activated charcoal. The proximate analysis are moisture content, ash content, volatile matter, and fixed carbon. The result of the proximate analysis after pyrolysis or oxidation method, there are air flow rate, yield, moisture content, ash content, volatile matter, fixed carbon, and based on this data, SNI 0637301995. The moisture content maximum 15%, ash content maximum 10%, volatile matter maximum 25%, fixed carbon minimum 65%. In figures 1 and 2 above, it can be seen that the higher of the flow rate, the lower the moisture content value, whereas the S content is directly proportional to the air flow rate. It can be seen that the yield continued to decrease along with adding or flowing air into the reactor, namely the more oxygen and nitrogen gas flowing. The yield and activated charcoal obtained also relativity decrease. This increase in water content is not only caused by an increase in the hygroscopic property of activated charcoal to the water vapor, but also due to the binding of water vapor molecules. For S content, the higher the flow rate, the higher the pyrolysis temperature and tends to increase the S content. In figure 3 and 4 above, it can be seen that the tendency of the higher the flow rate, the lower the volatile matter value. Meanwhile, fixed carbon tends to be directly proportional to the airflow rate. The higher the airflow rate, the higher fixed carbon. It can be concluded that the large amount of airflow into the reactor causes the temperature rise to be higher so that the fraction that evaporates in the raw material is mostly gone. The more air that is flown into the reactor causes the temperature rise to be higher. The fixed carbon also relativity increase. Relativity increase. This is due the perfect combustion or pyrolysis process so that the water component or fractional of water as and volatile matter will evaporate easily and will increase the value of fixed carbon. From research that has been done on airflow rate variation of 20 liter per minute, 25 liter per minute, 30 liter per minute, 35 and 40 liter per minute, the following conclusion can be drawn. The airflow rate reaches at its optimum condition at a speed of 35 liter per minute. At the condition above, the optimum activated charcoal is already experiencing a saturation point. The best results were shown at an airflow rate of 35 liters per minute with a product yield of 20.2%, 5.82% moisture content, 7.51% as content, 8.73% volatile matter content, and 77.94 fixed carbon. These results complies with Standard National Indonesia or SNA 0637309095 standard. Thank you. Thank you very much.